Hello, chemistry students. Here are your section review 6.4 corrections from page 156 in your textbook. Question 32 asks, how are formulas written for binary ionic compounds given their names? How is the reverse done? So if you're given the name of a binary ionic compound and you want to write the formula, remember there's 4 steps. We're going to do symbols, charges, crisscross, lowest whole number ratio. And again, we might do the symbols and charges at like the same time. So we write symbols, positively charged ion first. Okay. Charges, we, again, either it's a polyatomic ion we have memorized, it's in a tall column on our periodic table, or it's on our helper sheet to figure out our charges. We crisscross just the numbers, not the signs. We make sure we have the lowest whole number ratio. How is the reverse done is saying, if I'm given the formula, how do I write the name? When I'm given the formula and I have to write the name, remember I'm going to combine my name of the cation and the anion. And I have to be careful, some cations are going to have more than one possible charge. So again, if I have more than one possible charge, I should use both the stock and the classical system when I'm naming that cation. 33 asks, how are formulas written for ternary ionic compounds given their names? Right? A ternary ionic compound just means we have polyatomic ions in it. We still do symbols, charges, crisscross, lowest whole number ratio. We still make sure we write our positive ion first. We write our charges, we crisscross. The only thing we have to remember, right, with this is we have to use parentheses if we need more than one polyatomic ion. How is the reverse done? So if I'm given the formula, how do I write the name? I still combine my name and my cation and my anion. And if my cation has more than one possible charge, I'll use the stock in the classical system. 34. Write the name or formula as appropriate. So letter A, chromium 3 nitrite. Again, is this ionic or molecular? It is ionic because I have a metal plus ite is a polyatomic ion. So my symbol for chromium is Cr. Its charge is +3. That's what the Roman numeral is telling me. Nitrite is on my helper sheet. Nitrite is NO2 with a charge of -1. I crisscross down my charges. I'm going to need parentheses because I need 2 nitrites. So my formula is CrNO2 in parentheses, outside my parentheses of 3. Letter B asks us to name this. So again, we look at Mg and PO4, and we know that's an ionic compound. PO4 is one of the polyatomic ions you have memorized. Mg, that's in a tall column, so I'm only going to have to name this once. So Mg's name as an ion is magnesium ion, so it's going to be magnesium. And PO4 that you have memorized is phosphate, so this is magnesium phosphate. Letter C, I have to name it again. Again, lithium's a metal, fluorine's a nonmetal, so I know it's an ionic compound. Lithium's in a tall column, so I only have to name this once. So lithium would be lithium ion, so this is going to be lithium. And F is fluoride, right? Single atom, so it has to end in ide. It loses its element name and gets the ending ide. Letter D, sodium perchlorate. This I have to write the formula for. Sodium is a metal, so I know this is an ionic compound, plus I have that 8 ending, which tells me it's a polyatomic ion. My symbol for sodium is Na. Its charge is +1 because it's in group 1A. Perchlorate is not something I have memorized, so I'm going to use my helper sheet to find perchlorate, which is Cl O4, -1. I crisscross down my charges, which are both 1s, so I don't need any parentheses or anything, so it's just NaClO4. The next one, I need to write the name. Again, I have a polyatomic ion in a metal, so I know it's an ionic compound. So I have to look at PB, and is PB in a tall column or a short column? And PB looks like it's in a tall column, but it's underneath that heavy stair-step line, which means I need to check my helper sheet. PB is lead. Lead is on my helper sheet. So to be able to name this, I have to figure out the charge on this anion. And again, that's not one that I have memorized, so I look up on my helper sheet for C2H3O2, which is acetate, and it has a charge of -1. There are 2 of them, so my total negative charge is -2. That means my total positive charge has to be +2, and I only have 1 lead, so that lead's going to be a +2. So the stock system first, this is lead, Roman numeral 2, acetate. My other name, I look at lead on my helper sheet and it's plum. And the 2 charges for lead on my helper sheet are +2 and +4. So this is the lower charge one, so this is us. And then it's still acetate. Lastly, I need to write the formula for magnesium hydrogen carbonate. Again, I know this is an ionic compound because I have a polyatomic ion you're supposed to have memorized in it. So my symbol is Mg. Magnesium's charge is +2. It's in group 2A. Hydrogen carbonate is HCO3 with a charge of -1. I crisscross down. Notice I am going to need parentheses this time because I need more than 1 hydrogen carbonate. So it's Mg, HCO3 in parentheses. Outside my parentheses, a 2. Question 35 says, when are parentheses used in writing a chemical formula? When I need more than 1 polyatomic ion. Okay, so would we need more than 1 polyatomic ion, just like we did in that last example we just did. And 36, what condition must be met in writing a balanced formula for an ionic compound? Okay, my net ionic charge must be 0, which basically is saying that my total positive charge has to equal my total negative charge. So overall, I have to be neutral. I hope that helps if you had some questions.